Want to learn about subnetting? First, you have to know how to convert binary to decimal and vice versa. Are you ready? Well, let's get started. Hello, I am Janelle Pasayan and our group consists of Alisa, Jessie, Gio, and Ezekiel. We are group 5 and this video you will learn the basics of binary. The terms that we will tackle converting to decimal, decimal to binary, and many more.
First, let's start with the terms. Binary is a base 2 numbers system that is only made of 2 numbers, which are 0 and 1. This is the basis for all binary code used to write digital data and also the primary language of computers. We can group these bits together into an octet, which consists of an 8 bits. The host is the client and the network is the network. Subnet mask is a 32-bit number created by setting the host bits to zeros and the network bits to ones. This also separates the IP address into the host and network address, which help identify part of the IP, which part of the IP belongs to the device and which belongs to the network. If you want to learn more about how binary works or what it looks like, one of the easiest way to understand this is through conversion.
We will need a binary to decimal conversion chart and a decimal to binary chart. We have put 8 bits down here and we start from 1. Then we just multiply it by 2. 2 multiplied by 2 will be 4. 4 multiplied by 2 will be 8. 8 multiplied by 2 will be 16, and so on and so forth until we get to the 8-bit. Take note that we can keep going till 256 and 512, but for this example, we will just stop until 128. Now that we have put down the chart, we will start with the examples. So first question, we will start converting 1001, 1001 to decimal, then we will put 128, 64, 32, 16, 8, 4, 2, and 1 on top. Now we have the conversion chart on the top and the given binary example on the bottom. So, number 1. Look where ones are located. In this example, there are ones located below 1, 8, 16, and 128. Number 2. Check number that's from the conversion chart has 1 below it. There is 1 on the number 128, so bring down 128 on the third row. There is a 1 on number 16, 8, and 1, so bring that all down. Number 3. Combine them all together. So now, 128 plus 0 plus 0 plus 16 plus 8 plus 0 plus 0 plus 1. Add them all up and we get 153. What is 1001, 1001 in decimal? The answer is 153. As for decimal to binary, we will reverse the method we had earlier. Since we don't know what the binary bits are, we will number 1. Start from the left, then to right. Number 2. We will start with 128. Since 128 is greater than 76, then we will put a 0. Number 3. 64 is less than 76, so we will put a 1. Number 4. Is 64 plus 32 less than or equal to 76? No, it's 96. We will put a 0 there. Number 5. Is 64 plus 16 less than or equal to 76? No, it's 80. So we will put another 0. Number 6. Is 64 plus 8 less than or equal to 76? Yes, so we will put a 1 there. We are getting close to 76, which is good. Number 7. Is 64 plus 4 less than or equal to 76? Yes, so we will put the final 1. We already have the exact number we needed, so there is nothing left over after that, so just put 0 for 2 and 1. What is 76 in binary? It's 01 00 1100. Now that we know how to convert, we can proceed to subnetting.
We will now talk about subnetting. So first, we have three classes: Class A, Class B, and Class C. There are actually two more classes, which are D and E, but we will focus on these three. They each have their own default subnet mask, and classes can be identified by the number in the first octet of their address. To differentiate all of the classes, let's start with this. Class A. Check the first octet of the IP address if it is between 1 to 126. For example, 68.255.255.255. That is Class A. It also has the default subnet mask of 255.0.0.0. Now, Class B. When it comes to Class B, the first octet of the IP address is between 128 to 192. An example of Class B is 147.255.255.254, and the default subnet mask of this is 255.255.0.0. Lastly, Class C. Class C ranges between 192 to 223. An example of this class is 192.168.178.1. And the default subnet mask of this is 255.255.255.0. As you may have noticed, the number 127 isn't included here. Why? Because 127 is reserved for loopback and diagnostic functions. Now that we know what the classes are, we can start subnetting. Our example for this will be this. IP network address is 195.201.999.10. Subnet mask is 255.255.255.0. That is because this is Class C. 195.201.199.10 is equal to 11000011.1100011.111.000001010. 255.255.255.0 is equal to 111.111.111.111.111.000000000. We will now calculate on how this will be subnetted out. First, take the two addresses. Subnet mask and IP address and convert the decimals into binary bits, which we have already did. Second, we will now perform bitwise AND. If there is 1 in both subnet mask and IP address, we will bring it down. If there is a 0 on the IP address, we will ignore it and just put 1 on the bitwise AND. 195.201.199.10 is equal to 11000011.110000111.0000110. 255.255.255.0 is equal to 111.1111111.1111111.0000000. Now, after performing bitwise AND, this is the answer we got. 11000011 dot 11001001 dot 11000111 dot 0000000. Now, the answer we have for the subnet or network address is 195.201.199.0. In the network address, you can see that it is almost exactly the same as before, but instead of 10 as a host, it will become 0. For broadcast address, change all of the zeros in the host to 1. So now, broadcast address is equal to 195.201.199.255. Now, we will summarize what we got, or what we did in this video.
In this video, we learned how to convert binary to decimal and decimal to binary. We use this knowledge to subnet. Our example earlier was this. The IP network address is 195.201.199.0 and the subnet mask is 255.255. and 255.0, which is class C. Network address is 195.201.199.0, while the broadcast address is 195.201.199.255. The host range is 195.201.199.1 to 195.201.199.254. If you are wondering, why is there no 195.201.199.0 and 195.201.199.255? It's because we don't include the network address and the broadcast address, which has the 0 and 255. We hope you understand what we did in this video. Thank you for listening.